just like what? Just like this. Okay, maybe fancier than this and looks better, but it is still, for the most part, HTML code that people are pushing out. But within HTML code, what do you think can be contained that can be a bit dangerous? JavaScript. Okay, and JavaScript is enabled on most browsers because if you don't enable JavaScript, most things do not work. Okay, and JavaScript, has a lot of abilities. Okay, in other words, that's a big security hole. I mean, there's a lot of vectors through JavaScript to get into a computer system. So what they have done with Twitter is they did not do a very good job of filtering what stuff can be sent out, through the Twitter interface, and they accidentally allowed JavaScript embedded into the messages to be sent out through Twitter. And that's not good, okay? Because now, one tweet, you can have many people getting infected by, that's just one tweet. Especially if you send it out through Justin Bieber's account, that would be bad. Yeah. Then you have racks of servers, sending out all those infected messages. Lots of worms, yes. So anyway, but that's interesting because, as it turns out, the web is not secure. Not because the servers are not secure, it's not because the operating systems are not secure, it is because the web applications are not secure. That, turns out to be a bigger problem than, say, Windows or Internet Explorer and all those other things combined. It's because of how people write their scripts on the web that makes it insecure. Okay, any questions? No questions? Okay. Maybe, at some point we can have a class, that talks about hacking, like, how do you, poke a program and find out, whether you can find security holes, within the program. But they have a lot of tools, hackers of that type, have a lot of tools. In other words, they have, they have an X-ray of, a program in execution. They can tell what memory locations are being changed and what are the triggers, to cause, those, memory locations getting changed. Okay, and that's not easy, because, that's, both a software and sometimes it's hardware assisted in order to do that sort of monitoring. But that's the kind of tool that hackers need to use in order to figure out, how to hack into a program. Okay, so let's get back to your question. I still remember that. Your question is, how come x is less than 4 is the same as x is less than or equal to 3, but only if x is an integer. Is that the question? Sort of?
Yeah, but I can understand it, but I didn't understand how I can get it mathematically.
Okay. Okay, the question is, what is the largest integer that is less than 4? Right? That's it. You can prove it by contradiction too. You can prove it by contradiction. Let's say these two statements are not exactly the same. Okay? If these two statements are not exactly the same, that means somebody should be able to find me an integer such that it is true for one, but it is false for the other one. And based on that assumption, you can basically arrive at a contradiction that proves that the original premise has to be true. So with this class, where did we stop? I'm going to continue with new topics now. Can anyone tell me where we stopped last time? Or I can just watch my own video. Oh, it's okay. I'm almost there already. Are we done with pre and post conditions?
Yes.
We are?
Yes.
So we covered the loops also?
And then we were talking about the use of phrases if, only if, and if and only if.
Right.
The loop is not equal.
Okay. Okay, that's good. Thank you. Are there any questions about the if, only if and only if? No questions about that? Don't you guys realize that in programming, the way we use the if as the keyword of conditional statement is wrong? You guys don't realize that, right? Okay, let's think about it. Okay. Okay. Let's think about that, and I will try to capture that also in my notes. Okay. Now, this may not be a big deal. You know, most professors look at this and go like, yeah, it's not a big deal. But I think it is a big deal because, you know, by using the wrong term, you know, it is actually promoting bad, you know, reasoning. Okay. Okay. Let's just, you know, go with this. If A, then B. Okay, as a statement. Okay. Under this statement, you have 4 possible cases. In other words, A can be true, B can be true or false, and then you have the entire statement, if A, then B, being either true or false. Okay. Now, this is fairly abstract, so let's use another example. You know, I think I'm done with using Luke as an example, so we'll use something else. So we'll say if the sky is orange, then worms will rain down from it. Okay, whatever. Okay. Okay, that's my statement. Okay, you know, somebody, you know, pay me $10 and say, you know, Tag, say something smart, and that's what I said. Okay, so the question is, under what circumstances can that person get the money back and say, Tag, what you said is false. You know, I want my money back. Okay, so do you guys understand the nature of the discussion? Okay, so these are my words of wisdom. Somebody paid $10 to get it. Okay, so the question is, when can that person get a refund of $10 because what I said was not true? Okay, so now you have, you know, true and false and stuff like that. So we have, okay, let's say we can use, let's not use a table. Okay, so the sky is orange. As a statement, you know, when you walk outside, you can verify it is either true or false, right? Look up there and go, okay, the sky is orange, or no, the sky is not orange. And the same thing with worms falling from the sky. Okay, you go outside, you extend your hand, and oh, no, nothing, or raindrops, or whatever, or frogs, or fish, or whatever, but it's not worms. Okay, so each one of these, you know, can either be true or false. So let's think about the case when the sky is in fact orange, and worms are definitely falling from the sky. Can that person get the refund from me? Nope, because what I said is actually true. The statement itself is true. What about the case when the sky is in fact orange? You walk outside and chickens are falling from the sky. You know what? I'll give you your $10 back. Okay, because that's the only time that the observation contradicts with my prediction, with my statement. What about the case when the sky is not orange? Did I say anything about what happens when the sky is not orange? The statement saying that if the sky is orange, worms will fall or rain down from the sky is simply saying I should only be held accountable for stuff when the sky is in fact orange. I did not say anything about what happens when the sky is not orange. So that means if the sky is not orange and worms are falling from the sky, no refund, because what I said was still true. It is not contradicted. When the sky is not orange and no worms falling from the sky, no refund in that case either. Are we okay so far with this? Okay. So where am I going? I mean, so what? I mean, you know, that's what we talked about last time. Remember what we used in pseudocode, the conditional statement? So let's go ahead and take a look at conditional statements. Okay. If x is less than y, then we'll just do something, you know, simple here. So we won't try anything that's too hard. We'll just say that z gets a value of 0. Okay. And if, well, let's give it an else too. So here's the else here. Okay, so let's take a look at this statement in the context of using the word if. Now, according to this logic here, the behavior of this statement is if x is less than y, I definitely should put a 0 into z to be consistent. Oh, that's good. What if x is not less than y? Well, that's how we structure our code. That's how we understand our pseudocode. And by practice and practice and practice, we think that way already. But if you think about the statement up here, when the sky is not orange, worms can be falling from the sky or not, but either case, the statement is still true. So that means that this statement, not in the context of pseudocode in this class, really does not say anything about what happens when x is not less than y. You guys following? It's because of the word if was used. You guys okay so far? Because according to this, when the sky is not orange, when the sky is orange is false, we don't really care whether worms are falling from the sky or not, and the statement was still true. So when you translate that into our statement in pseudocode, that means if x is in fact less than y, we definitely have to say z gets 0. But when x is less than y is not true, we can go either way. Nobody can complain. Yep.
Is this the same as that if and only if?
It should have been if and only if. That is the way to fix it. So that means in every programming language, right, every programming language that I know of use the keyword if, which is actually incorrect. They should all be using if and only if, because if and only if means that when x is less than y, we definitely have to do this. When x is not less than y, we definitely have to do that. There's no saying, if it is false, either way is fine. Okay. Just minor detail, but I just have to point it out because when someone asks, but what about conditional statements? We use the word if. Doesn't it mean that if the condition is false, we have to go to the else branch? The convention is yes, but that would not be consistent with the way we explain it in logic. Okay. Any questions about this part? No. Don't bother raising this question with your other programming professors. They will just kind of ignore you. Because they don't pay attention to this sort of thing. It really has to do with people who write programs or invented most of the programming languages. They were not mathematicians to begin with. Okay, so we're going back to the same thing about the relationship of computer science and mathematics. Okay, because if a mathematician invented programming or invented a particular programming language, he or she would have used if and only if, because that's the correct mathematical way of specifying it. Okay, so that's cleared away. Have we started on the next topic, which is top-down design? No? Okay, so let's go ahead and get started with top-down design. I know we only have about 6 minutes left, but that's more than enough time to illustrate why we need top-down design. Most of the time when I explain the concept, I would much rather to spend more time on the why, the rationale of a particular concept, in addition to the mechanism of that concept. And my favorite example is maps.google.com. Why does that have to do with anything about top-down design? Can anyone point out where is ARC on this bitmap?